everybody. Hope you're having a good Monday. I know not a whole lot of people are enthused about Mondays, but I don't know, what can I say? It's got a lot of weather to look at here, and even a little bit of Venus. Figure we check in there, still in very prominent evening star. There's a little bit of close-up, and it's always amusing to think what's going on the surface of that planet. Very inhospitable there. Nothing like that on the surface map here, but we do have a Pacific system moving inland, and you can see that right there. Lots of what you can see, kind of a showery appearance back here, and that's because we've got the main cold core system moving inland. And then if we go to the south a little bit, you can see what looks like more of a baroclinic leaf pattern. So this is getting more into the stratiform precipitation out ahead of the cold front. And roughly it's about something like that. So we're going to be looking for that on the charts here. Okay. Switch over to the main charts. Got a lot of warm air up in Ontario and Manitoba once again. And pretty much everything west of the Rockies, cold. Everything to the east, warm. And as you might guess, we've probably got a little bit of that going on with the upper level patterns. So upper level trough over Nevada and California, and probably a bit of ridging over Ontario here. So that's what we'll be looking at on the charts. Conditions very warm here in Texas. We've seen 70s and 80s in some areas, and you can see you get south of the border there, 90 degrees. But much cooler out to the west where that upper level system is moving through. We can see lots of 30s, 40s, and 50s. This is not super cold air, but it is certainly below normal here. Here's the satellite chart. This is infrared, as it is nighttime across the U.S. So we're looking at temperature here, and you can see a lot of open cell cumulus offshore. So this is the convective cells associated with the main upper level system, and the center of it probably back in here. Then off to the west, you can see a little bit more of that baroclinic area. So probably the jet stream is going to be running possibly something like that right there. And here's the 500 millibar chart. Trace out the jet. Goes basically from San Diego into Colorado, and then down into Oklahoma and down to Florida. So pretty far south. Pretty good active southern stream here. We do have a northern stream across the Canadian Arctic. And in between, just this area of low heights. So this corresponds to where a lot of the cold air is developing right now. Embedded in that, there are going to be waves moving through the flow. And you can see, looking at this, it's kind of hard to piece out exactly where that is. Now we might look between maybe that station and see a tiny bit of cyclonic curvature. But this is an example where it's better to look at the models. And let me show you, where did I have that chart? Yeah, there we go. Let me set this on the current time. Actually, let me get that centered. Okay, so this is heights and vorticity, so this kind of brings out the smaller scale detail. And we can see mostly what we have is channeled vorticity patterns. The upper level jet kind of running in between this area, between the cyclonic vorticity to the left and the anticyclonic to the right. And as you might guess, for some of you who have been here a while, we would find the main jet stream kind of bound very tightly with these channel areas, right where I'm drawing this. So that's going to be a jet max right there. And then if you remember the 4-cell appearance, This is in some of my books here, and you can find this on the internet. Look for 4-cell jet streak or 4-cell jet stream, and you'll find that the left front quadrant is going to be in this area here. That's where we're going to have upward motion, cyclogenesis, so we're going to look for that over the four corners area. And then just behind we have a little area of left rear activity. So this is where air is flowing into the jet. We've got upper level convergence, and we get subsidence here. So we're going to look for height or pressure rises at the surface just off the coast of Los Angeles right there. So conditions improving right there, but you can see another jet max coming down the back side. So these are kind of small scale details in the data. And as you when we get to small scales like this down to hundreds of miles, we're talking changes on the scale of hours. So this is kind of getting into what we're looking at as far as severe weather, and it's possible if we look very closely at the data and look at consistency, look at the satellite very closely, we can almost get down to minutes and tens of miles. And a prominent example is the 1999 Moore tornado. They were tracking a little impulse wave coming out of New Mexico, and that factored into storms that fired over Oklahoma later that day. Now, a closer way we can look at the 500 millibar chart is to look at AWIPS. I'm trying to work this in where I can. As I've mentioned, this is what the Weather Service uses. This is a display and analysis system. And this is basically exactly what they're looking at in Weather Service offices across the country. So this is 500 millibar heights and vorticity here. And you can see that jet max coming through here, and I'll zoom in a little bit closer. That jet max is going to be right there, right over the northern Gulf of California, which is south of Imperial, El Centro, Yuma. And then that left front quadrant is going to be in this area here. I don't seem to have a good color for this. I guess we'll try that. So four corners area right there. And we do have right front quadrants and right rear quadrants, like right here. But when you're talking about cyclonically curved flow right here, these quadrants on the right side tend to be indeterminate. They're kind of canceled out by the curvature. So the rules that you would expect to follow on that side of the jet may not work so well. And we can see out ahead, even further downstream, there's probably a little bit of upward motion working on Kansas here. And then as we get into Texas, the flow is pretty indeterminate. It's very neutral, not much going through that area. So that plus the ridge giving us clear skies like you saw in the intro. All right, let's take a look at the surface analysis and figure out exactly what's going on here. So you can see very strong bunching of those thickness lines right here over Arizona, over Baja California. And we'll be looking for that front kind of in this area here, coming into northwest Mexico towards El Paso. And then the warm front probably somewhere over Texas. Could be anywhere between here and up here. And considering it was kind of warm in Texas, maybe I would throw that up here in Oklahoma. So we're starting to look at maybe that for our frontal analysis picture. And it is very tricky there in the mountains. That's a very challenging place to find and analyze cold fronts. So you have to kind of look at all the data you have, along with the upper level jets. So we kind of factor that in, and the upper level jet kind of tells us maybe the front is, this kind of falls on the back side. We are going to find the jet stream and the jet max north of the front. So this front actually falls in very well with where the jet stream is, where the jet streak is. So everything here is got good consistency. Okay, I did load up some PC grids, and believe it or not, I've been doing this for the past week or two, but I keep forgetting to bring out wind grids here. And I've got data loaded in. I've got the NAM, and I figured we could run a cross-section through this area right here, say from northwest Mexico up to maybe Tonopah or Area 51, kind of in here. And that area right here is under the upper level low pressure area. So this is basically the cold core aloft. So let's see if we can analyze that real quick. I'm going to go to set a cross section. Actually, I've got to define that first. Let me try that again. There we go. If you're working with wind grids, you're going to bring up this cross section setup and go to map select, and hang on just a second. I'm trying to get this window to come up here. I've got a window stuck at the very top of my map, so I'm going to have to do this off screen. Here we go. That map was really stuck up there. Okay, let me see if I can do this. Okay, we set our dot here on northwest Mexico, one dot, and then the other dot, we'll stick that over Area 51. And we'll do OK. And now that we've got that defined, we want to look at the actual products. So I'm going to go to Products, and then we'll go to Cross-Section Diagnostics, and I'll select this, and here we go. So this is pretty interesting here. I'm going to set that on stop, and I'll pull up the grid. So basically, this is the ground. This is northwest Mexico here. This is Arizona. This is Las Vegas, and then your aliens, Area 51 right there. So upper level jet sitting right above basically southern Nevada into northern Arizona. And you can see sloping of the potential temperature surfaces. So our cold front's going to be kind of sloped somewhat like that. And you've probably seen this in textbooks. That's our cold front, cold air mass right down here, and then the tropical air mass up above that. And that slope right there is actually what causes the jet stream to appear in the upper troposphere. And the other thing you can see here is the difference in the tropopause height. Over Nevada, it's very low. Then as we go over Arizona and Mexico, tropopause a lot higher. This is up at about 38,000 feet. This is probably about 23. And let's see how that changes over the next few days. I'm going to run an animation, and you'll see how this changes. And here we go. It's going to take, this is going to be 12-hour time steps. So this is for noon. This is midnight. You can see it kind of shifting to the west or to the southeast. There's another time step. You can see a lot of the slope here, and all the gradients are concentrated in the mid-levels of the atmosphere here. So this is probably a very deep cold air mass. Then we see things moderate a little bit here, a little bit of air mass modification, and then the surfaces start flattening out there. And then another way we can look at that is to bring up soundings. Here's Las Vegas. Looks like a very steep temperature profile here. That's definitely conducive to showers, because if we lift a parcel and maybe bump this up down here for afternoon heating, we get some decent cape in here. And we get low tops. Tops on these, if we balance that out for the equilibrium level, that's going to keep the tops well below 30,000 feet. And the tropopause height here, about 25. That's very low there for Las Vegas. And then further to the south, Tucson, they're more in the tropical air. And I'm not sure exactly where the top of that cold front's going to be. I think they are back behind the cold front, and this is where this is where cross sections can really help us out here. We can figure out if the station is behind the front or ahead of the front. And then one more I'll pull up here is El Paso. I think El Paso is going to be out in the warm air. And tropopause a little bit high, up at 39,000 feet. Very steep lapse rates near the surface. Very strong winds aloft there, 110 knot winds. But we are lacking moisture out there, so no showers to deal with there at El Paso. Okay, I'll take a look at chat here, see what's going on. Let's see, we got most of our regulars here. The new GOES weather satellite pictures are amazing. The ones I'm showing, yeah, we'll try to put those up more. Oh, GOES 16, okay. Yeah, I'll look for that right there. What causes the jet maxes to occur? That's a result of the difference in the air mass from one side to the other. I don't have a good cross-section here to show you, but the jet max, the jet streak is there. Let's try that again. The jet stream is there because of the difference between cold air masses to the north and warm air masses to the south. So the slope of the front, like I mentioned, is actually what produces that jet stream. Let me see if I can run this real quick. Yeah, what's happening here, this is out back behind the cold air. The density of the air mass tends to result in very tight thickness, and as you stack the thickness higher and higher, you end up with the height of pressure surfaces in the upper levels to be actually very low compared to where out in the warm air mass, the surfaces will be spread out a lot more. So when you actually connect the surfaces, they're pretty much at the same level. This might be like 1,000 millibars here. This might be 700. And you can see that the slope gets steeper and steeper as you go higher and higher. So as a result, the pressure gradient in the horizontal gets steeper and steeper, stronger and stronger, and the winds increase between those two areas as you go higher and higher. And this is also mentioned in some of my books there, so you can look that up. Okay, let's head into the forecast and see what's coming up over the next week. And here we can see the Pacific system moving inland. So a cold front may be something like this, warm front in Oklahoma. So very strong cold air advection coming into Arizona, and very showery conditions back in Utah and Nevada there. So we're going to see the front progress eastward, and by the time we do the webcast tomorrow, we're going to see the front coming into West Texas here. And then the main baroclinic system will be up in Kansas. So there's a warm front coming up into Sioux and Sarah's area around Indiana. And not much precipitation associated with that. And this probably will be quite a warm day for Texas. Southwesterly flow ahead of the front. Should really warm it up in the Dallas, Houston, and Austin area. Then the webcast for Wednesday. We'll see the front continue through the rest of Texas. Cold air advection coming down into the state. And this high pressure area in the Great Basin area will be building and cooling down. For Thursday, cold front well to the south. Another cold day. Very boring weather. For Friday, it looks like an upper level system tries to pick up this boundary a little bit. You can see a little bit of showers down to the south. And high pressure over the Great Basin area building as we get continued cooling there. And then down to the south, you can see things pick up a little bit south of Corpus Christi and south of Houston. So pretty much it looks like a mild to cool weather for the next week or so. Not much going on. Get one little Alberta clipper coming through on Monday. And that'll probably cool things down quite a bit. This is around February 1st right there. So very strong cold air advection coming south. And then the GFS tries to build in this winter weather system around February 5th. It's quite a ways off, so we'll see what happens with that. And that's probably about it right there. So looks like we're finally getting into a dry pattern, and the next Pacific system, let's see when that is. Things pretty quiet there in California. January 25th, 26th. Pretty quiet, and then you see the Santa Ana winds starting to build across California this weekend. So things quiet down, and I guess we're just going to be under the influence of this upper level ridge. Northwesterly flow into the U.S., and should be pretty quiet here for a while. And I'll take a look at the Canadian model and see if there's any unusual changes, any unusual differences between that and the GFS. And not really. Looks like the Canadian model is a little bit cooler. See that 516 decameter building across the Midwest. So they're going for some very cool air in that area. And otherwise, just about the same as the GFS. Sneaking a little bit of precip here on February 2nd into Texas. So we'll see what happens. That's 240 hours out. So there we go. That's the show for tonight. Kind of quiet there. And anyway, I hope we'll see you tomorrow, and I'll see what's going on with that GO 16. I missed that. We'll check that out. Anyway, we'll talk to you tomorrow. Thanks for watching.